Alright, so we're going to introduce you to a concept called literal equations. Now what literal equations are equations that contain more than one variable. So up until this point, we've been working with 5x plus 7 equals 14 and solving that with only one variable x. But a literal equation is going to contain more than one variable, something like d equals r times t, which you might know that as distance equals rate times time. We could have P equals 2L plus 2W, or perimeter equals 2 times the length plus 2 times the width. P will depend on what L and W are. You've even seen these in linear equations where we have y equals mx plus b. So most of the time you're going to see literal equations when we're working with formulas. We have the distance formula, we got perimeter formulas, we got area formulas. This is where literal equations appear most often, even the quadratic formula. So a quick review of the 3 rules of solving equations. You can do anything you want to an equation as long as you do it to both sides. If you're working with addition and subtraction, you can solve an equation by making a 0 using inverse operations, and if you're working with multiplication and division, you can do anything you want as long as you make it a 1 using inverse operations. Okay, so here's an example of what a literal equation might look like and how we can solve it. If I have A equals B times H, or you might recognize this as area equals base times height, and I want to solve this equation for B, if that's the goal, to solve the equation for B, then all I have to do is divide both sides by H. Well, how do I know to use division? Well, because B and H are held together by multiplication. So to get B by itself, I need to get this side of the equation, the right side of the equation, to be 1. And so if I divide by H, then the H's will reduce on the right-hand side, and I get B equals A over H. This is an abstract problem because there are no numbers involved. So I can't say B has a specific value until I know the values for A and H. Once I know the values for A and H, I can figure it out for B. So that makes these problems just a little bit more tricky because they're so abstract and there aren't many numbers in the problem itself. Here's one where we're solving for L. Perimeter equals 2 times the length plus 2 times the width. So the goal is to get that L by itself. You could treat everything else as if it were a number. All right, that's a good tip right there. Treat it as if it were a number. So if I was trying to solve for L and 2W were a number, the first thing I would do is I would subtract a 2W. Because I'm dealing with addition, I have to use the inverse operation. 2W minus 2W gives me 0. And on the left-hand side of the equation, I have P minus 2W. I can't simplify that any further because I don't know what P is and I don't know what W is. Now to get this L by itself, I have to create a 1 on the right-hand side of the equation. So I'm going to divide the right-hand side by 1, and I'm going to divide the entire left-hand side, divide by 2, divide the entire left-hand side of the equation by 2. So I get L equals P minus 2W over 2. And that would be my answer for that one. One more example. Here I have a formula. Now I have no idea what this formula represents, but I see that I got 3 variables. I got a Q, a C, and a D. And the idea is to get this D by itself. We have a couple different options here when we're solving for D. One option is we could distribute the 1/2 through and get 1/2 C plus 1/2 D. That would be perfectly okay. But perhaps a little bit more efficient way is, since this 1/2 is held together to the C plus D by multiplication, I can force a 1 by multiplying it by 2. Multiplying the 1/2 by 2. 1/2 times its reciprocal, 2, is equal to 1. So in that case, since I multiply both sides by 2, I end up getting 2Q is equal to C plus D. And now, to solve for D, all I have to do is subtract a C from both sides. So I get 2Q minus C is equal to D.